You're messaging your goats?
Coach.
Coach?
Definitely goats.
Goats, yeah. All right. Okay, you guys are paying attention because you're looking at your notes, right? Okay, let's try this again. All right. Class.
Yes.
Thank you. All right, so we're going to be doing this. We're actually starting our calculus sections. So the other stuff was just algebra stuff. Now it's calculus. All right, so rates of changes and limits. Now, what a rate of change actually is like miles per hour. That is a rate of change. It is distance over time. Okay? If I were to graph it, it would be a distance over time, which is going to be slope. Calculus is all about slope. That's all it is. The slope. You're finding the slope and methods to find the slope. Everything is about finding the slope. We can even find the slope of the slope because the slope's going to curve, right? And if we have a graph and it's actually distance over time is going to give me my position. So if I, am walking at 1 mile per hour and I walk for an hour, my distance would be 1 mile. My time would be an hour. Distance over time. Okay. Now, am I doing that over the entirely same course? Maybe. Maybe I decide to jog for a little bit. But the distance over time, that's going to be a rate of change. So if we were to actually take that and then the rate of change of the rate of change, I could actually have my velocity, which is going to give me my speed. And if I take the rate of change of that, it's going to give me my acceleration. Am I increasing? Am I going faster? I'm still going forward, but am I going faster or am I slowing down? But I'm still going forward. So it's possible to go from here to Douche over there. How far is it from here to 7th Street? It's like half mile, right? Okay, let's say half mile. Anyway, but yeah. So the distance from here to there, and then we don't, even if you're driving, you're not at a constant speed. So you could actually get the average speed from how long it takes you to get from point A to point B and the distance that you cover. But all those change. So that's everything for calculus. Average velocity would be velocity of a moving body during an interval of time. And it's found by dividing the change in distance or position by the change in time. Delta y over delta x. So it's the change in y over the change in x. Or, okay, average rate of change or average velocity is the ratio. So the function of t plus delta y minus f of t divided by delta t. So that's the change in time, where delta y is actually going to be whatever you're going to have in that change there. Where the elapsed time is the interval from t to delta t, or simply delta t, at the distance traveled during this time is the interval of f of t plus delta t. Free falling object. Okay, experiments show that a dense solid object dropped from rest to a fall freely near the surface of the earth will fall at y equals 16t squared feet in the first t seconds. That is standard, always. So when they're talking about stuff falling, okay, they're going to be using this. Sometimes they're going to talk about throwing it first, but falling is going to end up at the same rate. So, because gravity pulls on stuff and it gets to an equilibrium. Even if I throw it down hard as I can, but if I'm top of a building, by the time it hits the ground, it's going to be at the same speed as what it would be if I were to just drop it when it hits. Even though I throw it down, it slows down because it's not just continually increasing. So there's a thing called terminal velocity, where there's only a certain speed that it could go because it's falling at a certain rate, and there's also a wind velocity that is actually trying to parachute it. Kind of like when you throw a cat off a roof, okay? the cat will just and then I watched this video about how cats are, are like broken if like video game physics. They actually had a cat that fell off the 39th floor in New York City, survived.
Why is it on the 39th floor? Okay.
They live on the 39th floor and the cat decided to jump off. I don't know, maybe he had the wrong type of cat treats or something. I don't know, cats are assholes. Anyway, so jumped off and it did like this weird thing where has like a terminal velocity and then apparently just like broke his tooth. So as it landed, it just broke his tooth. 39 floors.
That would break his legs first.
Nope. Apparently cats have some like super crap terminal velocity.
Okay. Sure,
Fatty.
sure.
Anyway, but still, yeah, I don't even know why I was thinking about. I was like, I think I mentioned it, and then my phone picked it up and then started to show me videos of throwing cats off a roof. Okay, so right now, since everyone's phone's listening about throwing a cat off a roof, you guys are all going to get ads for this now, or video recommendations about throwing cats off a roof, throwing cats off a roof. Instantaneous velocity is the speed of falling rock is always increasing. If we know the position as a function of time, we can calculate average speed over any given interval of time, but we can also talk about instantaneous velocity or instantaneous rate of change. The velocity at one instant of time, as we'll see after the next example, we need to have the idea of a limit to make precise what we mean by instantaneous rate of change. Now, I throw something.
Yes.
How fast is it going at exactly 2 seconds? No. How fast at that third? So is it still increasing in speed? Is it starting to decrease in speed? But it's still going forward. So the instantaneous velocity would be, what is the speed at that certain point? So how fast is it traveling? What is the rate of change at 3 seconds or at 2 seconds or something like that? That's what this is going to be doing. Okay. All right. Formal definition of a limit. Let C and L, L being capital, refers to the limit. Real numbers, the function f has a limit. L as x approaches C if given any position of number that's epsilon, it's lowercase epsilon. There is a positive number, delta, lowercase, that's a lowercase Greek delta, such that for all x, right here, the absolute value of the function of x minus the limit is less than the epsilon, wherever absolute value of x minus c is less than delta, and x cannot be equal to c.
And I did not understand how. That hurts.
But you're going to see epsilons and deltas later on. Okay, but as part of our definition of a limit, you're going to get these for the epsilon deltas, where it talks about a function where it all gets compressed down to the limit as x approaches c of the function f of x is going to give me my limit L. So L is going to be the limit I'm looking for. So I'm looking for the limit as x approaches c. So basically, this is my input, my output is my L. So I'm going to have an equation here, and my output is going to be the limit of that function. That makes sense or no?
Yeah.
Okay. Just pretend and say yes anyway. All right, the sentence, limit x approaches c, f of x is L is read by blah, blah, blah. L simply wish by restricting the distance between x and c, but not allowing x to equal c. The following example illustrates that the fact that the existence of a limit as x approaches c never depends on how the function may or may not be defined at c. So here's examples. Now, the limit refers to x. Where is x going? What is x doing at a certain thing? So the function has a limit 2 as x approaches 1. So as I'm reading, as x approaches 1, my limit is going to be right there, which is 2. So the limit's going to be 2. Now, on this problem right here, that is referred to as a hole. That is, it is undefined at that singular point. That is a hole. So there is a continuity issue here. So there is a hole there, but it is approaching the number 2. That's important. So as x approaches this, now also as part of this definition, it has to approach it from both sides. So as x approaches 1 from the left, it's going to be 2. From the right, it's also going to be 2. Because left and right are both approaching the same number.
Oh, if I just keep going straight.
I know, but as we're talking about a limit now, so as it is approaching the number 1, that's what it's asking for. As it is approaching 1, is it approaching from the left and is it approaching from the right? If both are approaching the same number on the graph, that is my answer. But right here, it is undefined at that point, but the limit does exist. Now on this one here, I have a piecewise. Come on now, right here. So from the left, it approaches 2. From the right, it approaches 2. But is the function defined at 1?
No.
Say yes. Yes. Why? See this right here, solid dot?
Yeah.
So there is an answer at 2. An open dot means it is undefined. There is a hole. There is a continuity. It is a roller coaster with a hole in the track. Okay, so if you're on a roller coaster and it has a hole, is that a good thing?
No.
No! You don't want your roller coaster to have a hole. So, right here on the second one, as it approaches 1, it is defined, but guess what? The limit is still 2. But it says g of 1 is not equal to 2. But the limit is still 2. The function is going to give me a different answer. But the limit is what is the left and right approaching. And then this last one right here, this one is continuous. So this one, the left approaches 2, the right approaches 2, and then it is defined at 2. So the function h right here, so it's going to give me 2 on both. So it's the limit and the function is going to be equal to 2 here. So this is a continuous one. Yes, no, maybe?
Yeah, I see. Twice function if it's not where to.
So if we're talking about a limit, left side and right side both go to the same number on a graph. That's the basic definition of that. Like super easy. On your graph is the left side and right side both going to that number. Properties of limits. If L, M, C, K real numbers, then, okay, sum rule. If I add the limit of both functions, it's basically whatever my output is for the limit of f and the limit of g, I just add those two together. So the two limits will add together. Same thing for difference rule. It's going to be this subtraction of those. The limit of f minus the limit of g is the same as L minus m. It'll make sense here a little bit. So hopefully you're not falling asleep too bad. Product rule, so if I multiply two limits together, it's going to be the same as multiplying their answers. This right here, k, was a constant multiple, so it is times my function of the limit. It's still going to be k times the limit. Quotient rule, if I have two limits divided, I just divide my two limits where the limit of m cannot be equal to 0. Why can I not have 0 in the bottom of a fraction?
Because
It is undefined. That's what we're looking for. It's going to be undefined. Power rule, if I'm taking the limit of a function raised to a power, it's the same as taking that limit to a power, whatever the r over s is. Now, you guys remember when we talked about this the other day, r in the exponent, right? What would r normally be? So, for this one right here, this r represents what? You guys remember we talked about it last week.
is it about the rate? No.
Not rate. No? You guys all forgot?
Yeah.
Everyone just waiting for me to say something? You guys remember where if it's in a fractional exponent, it's always power over root?
Yeah, now.
So, yeah, it would be the power over the root.
But you use a number, please. I don't know, like.
Okay, so if I had x to the 2 over 3, that'd be the same as the third root of x squared.
Okay, that's better.
Is that a better way of saying it?
Yeah.
Okay. Other properties. So if you notice, the limit of a constant is just that constant. And for this one right here, so it's going to be, there's no variables to plug in there. This one right here, the limit as x approaches c, you just plug in the c value and you get that value. All right. So for these, here is the super basic, easiest part. We look to see, are we going to have any problems? Is there going to be any restrictions or any weird things that I'm going to undefined or imaginary numbers? Say no. Not in this one. So all we're going to do is, as x approaches c, evaluate it at c. So if I evaluate it at c, that would give me 3c cubed plus 2c minus 9. That's it.
That's it.
Pardon the interruption, staff and students. Just as a reminder, internet is back up. Servers are back up at this time. Thank you.
All right. Polynomials, rational functions. I'm just going to go, let's do this one. All right, here's another one, a limit. As x approaches 5, I don't have any weird things in this problem that I might have some issues with. So let's just plug it in. So this is going to give me 4 parentheses 5 squared minus 2 times 5 plus 6. So as you guys are actually doing this on your homework, I'm hoping you at least, so let's say for instance this is number 2 on your homework. You said that was number 2, you write out the problem, you write out your steps, and then when you plug it in the computer, you're only going to plug in the answer. That's all it's asking for, is to make sure that your answer is correct. Let's finish this and okay.
Oh, we're still writing that.
We're still writing.
I thought you said.
Yeah, we're still
the
writing.
answer, and I'm like.
No, we're still writing. So this is going to be 25 times 4 is 100 minus 10 plus 6. So that's going to give me 104. So this 104 is going to be the answer you enter into the computer in MyLab. This is what you're writing down on your paper to show your work. So you're still going to have to show work for all this stuff. Okay, it's just you'll be able to check your answers, and if you get it wrong, you hit new problem, and then you could actually do it again, but hopefully get it right this time. I believe it gives you 3 chances first before it gives you a new problem.
Feels like MOER.
Yeah, whatever that is. So, evaluating limits. As with polynomials, limits of many familiar functions can be found by substitution at points where they are defined. This includes trigonometric functions, exponential and logarithmic functions, and composites of these functions. All right, so take out your calculators, and we're going to solve this one graphically. So 1 plus sine x over cosine x. All right, so second button is going to give me the scratch pad, and then hit scratch pad one more time. It's going to bring up my function. Now I'm going to do my fractions, so that's going to be control divide 1 plus sine. So right below control, there's a trig button. Yep, and hit scratch pad again to get the graph. Sine x, close, over, what was it? Was it over cosine? Yeah, over cosine. And in calculus, we always use radians. So all you have to do is take the mouse right here where it says degree, just click that and it changes, changed the rad, damn it. Okay, so I got to do it again now because it's being a pain. 1 plus there you go. And hit enter. Yes, a bunch of squiggles. All right, now what's my question asking?
Find the limit from x to 0.
Okay, so the limit as x approaches 0. Okay, so a limit as x approaches 0. So as x approaches 0, so from the left side, it looks like it's going where?
1.
Yeah, it looks like it's going to 1. So watch this. I'm going to hit menu, graph trace. So right here, trace. Or you could even analyze graph, but it's easier to just trace it. And right here, it gives me my coordinates. So when x is 0, y is 1. Okay, so that's good. So the limit exists and the function exists. So confirm analytically. So we're going to do the math. We're going to do the math now. So we're going to say that 1 plus sine at 0 divided by cosine at 0. So we're doing it analytically now. What is sine at 0? It's almost like I gave you a whole bunch of flashcards that actually had these things on it. But some people don't ever want to remember them. Everyone has one? All right, so let's try this, and this is going to be something that you're going to have to know, especially coming up here real soon. You have to know those. So there, I gave you flashcards for a reason. So whenever you have some extra time, you should be going through your flashcards, trying to remember some of these things. So sine at 0. Sine at 0 is
0,
0 plus 1.
1,
Okay, cosine at 0.
1,
And 1 divided by 1.
1.
So we could say that the limit as x approaches 0 of 1 plus sine x over cosine x is equal to 1. Oh, okay, so a couple things you can do. Control here, right?
Opposite here.
Dark B actually clears everything.
Okay.
So I didn't know how much. All right, now solve graphically. Now my function is 5 over x. 5 over x. So clear it. I'm going to do doc B so we can start over again. Go back to this. Control, divide, 5 over x. Hit enter. Now, we want the limit to go 0, right? As the limit approaches 0. So what did I say the limit had to do? When we were looking at our graphs before, what does our limit have to do? Okay, so the left side and the right side have to both go to the same point, right?
Yeah.
So, and in this case, my point has to be 0. So what is the left side here? As the left side is approaching 0, where is that going?
Going down.
It's going down to,
Negatives, infinity.
yeah, it's going down to negative infinity because there's actually going to be an asymptote here. But what about the right-hand side? What is the right-hand side approaching?
It's approaching positive infinity.
It's approaching positive infinity. So are they both approaching the same thing?
No.
No. Okay. So the left side and right side have to approach the same number for the limit to exist. This one, the limit does not exist. So graphically, okay, we can confirm this one here. So if we plug it in, it's going to be 5 over x, which is 5 over 0 undefined, but that isn't enough. So the left side, if I was going to do this, I would say, let's see, what's 5 over negative 1 would be negative 5. Okay, let's try the right side. So 5 over positive 1 would give me positive 5. So by picking numbers to the left side and to the right side of this, because for a limit to exist, the left side and right side both have to go to the same number. But if you notice, the left side is at negative 1 is going towards negative 5. But as I get closer and closer to 0, it's going to get even larger negative numbers. On the right-hand side, same thing's going to happen. So as I get closer and closer to 0, that one's going to get larger and larger numbers.
No.
So, yes, so that one is not going to exist. Now we're going to talk about one-sided limits. So now, if you see right-handed limit as x approaches c from the plus side, so that means plus side, that means it's only going to exist on the right-hand side. Left-handed limit is approaching it from the left-hand side. It's approaching the number. So this one right here does not have to be left side and right side. So now that's why it's referred to as one-sided limits. So now a one-sided limit would be just one side is going to the number. So a two-sided limit is the definition that we have, that the left side and the right side both approach the same thing for that to exist. Limit to exist, left and right side both have to go to the same number. That's my two-sided limits. All right, so here's the graph. Let me trace it out a little bit better so we can see this. There you go. So, A, let's look at A. So the limit of this function as x approaches 0 from the plus. So that means it's going to be which side?
Positive side.
The positive side, the right side.
Right.
Okay, because it's not always going to be a positive. We might be dealing with all negatives. So it's the right side. So if everything's over here on this side, you can't just say positive side, right? Because if everything would be on the left side of my graph, that means all my numbers would be negative. That's why you say from the right side. Yeah, so over here, if it's over here, this would be positive. But over here, this is negative. So that's why. So now, from the right side, as the function approaches 0, what is my answer? Look at the graph. What's it look like it's going to? Yep, it's approaching 0. My graph is approaching 0. Right? Does that make sense or no?
But what about the other one?
It's not asking that yet.
Oh, okay, wait.
It just says my function approaching 0. So that's the only part you're looking at,
So you look at
where
the-
it's approaching 0. Okay, the limit of the function as x approaches 2 from the right side. Okay, if you look, here's 2, isn't there? And that's right there. But in between there, isn't there a gap there?
It would be undefined.
No limit exists.
Okay, no limit.
No limit exists because there's a gap. So right here, their function there's nothing there connecting right here on the right side of the 2.
Oh, is that why it's not?
There's a gap. No limit exists because nothing from the right side is approaching that.
Oh, okay, so undefined is 2 lines.
Nope, undefined is divided by 0.
Oh, okay, divided by 0.
I think limit has one M, doesn't it?
Yeah, limit.
Yes, and it's right here in front of me because I'm kind of a moron.
Me too.
I know. Okay. Now, how about as x approaches 2 from the left side? It's not 2. Look right here. So as it's approaching 2, the y value is,
Still no limit.
it's going to be 4. Because if you follow the graph, as x approaches 2, this way, I want my y value. So my y value is going to be 4. Even though that it is a whole, isn't it? Like the function does not exist, but the limit is only asking, what is it approaching when it's going towards 2? This one's 4.
So just approaching from where all the lines up.
Follow the line, right? Follow the line, and I'm looking for the y value. Because as x, those are my x values that I'm using to approach.
Okay.
Now, let's look at the next one. So as x approaches 2, is that one-sided limit? No. That's two-sided limit, isn't it?
Yeah.
So for the two-sided limit to work, what has to happen?
It has to have the other
Left and right side both go to the same number.
No limit.
No limit exists. Now, the limit as x approaches 3 from the right side. X approaches 3 from the right side.
0.
It is going to be 0 because that's what I'm looking for. I'm looking for my y values there. As it's approaching 3 from the right side, my y value is going to be 0. Does that make sense?
Yeah.
So I think that's where I was going to leave for today before we get to squeeze theorem. So I'm going to pause here. We're going to pick up more of this tomorrow, and then I'm going to give you some time to get into your homework assignment. So make sure you all like, share, and subscribe. Hit that notification button. Support my channel. And then let's go to Canvas. I'm going to pull up Canvas right now. So here's Canvas, my calculus. There we go. Open it up. I had you guys all register all ready for this. And then for you, you're going to start assignments. Assignments right here. Here's the assignments. And so you're going to do 101. So it's chapter 1, section 1. So you're going to click on that. There is 25 questions here. So over the next couple days, 25 questions is going to be pretty easy. So you go here, just like I was showing on the notes.
Yeah, Wi-Fi closed stuff.
I know, that's why they had to do an announcement that our stuff was working, supposedly.
But
Anyway, so you're going to write down your problems, and then I'll try it again. You're going to write down your problems, and then in the box here, you will put your answers. And then you check your work, and then you don't have to submit all the rest to me. So right here, so for A, this is saying evaluate the function at the indicated values. Okay, so it says f of 0. Plug in 0 here. My answer is, so 0 squared times 2 is 0, minus 8 times 0 is 0, plus 7 is 7. Check answer. Yay! Now, of 5. We're going to do the same thing of 5. So it's going to be 5 squared is 25, times 2 is 50, minus 40. So that's 10, plus 7 is 17. There we go. So it's basically you have to write those out. That was it. Write those out, put in your answers, and whatever work you need to do for this, you could write it down. Because it is going to be necessary later on. Not so much on this one, because when we actually start doing the limit process, then that's going to get more interesting.